Welcome to another tutor short provided by the Educational Support Services Department of Lehigh-Carbon Community College in Snexville, Pennsylvania, which is just outside of Allentown. These videos review key learnings for the science courses provided here at lccc. And please remember that the Educational Support Services Department does provide walk-in tutoring 5 days a week. With this video, we're going to look at a very powerful methodology when doing science problems. It's called dimensional analysis and has a lot of utility when you're doing your homework or problems. Now, to begin with dimensions, when we're talking about dimensions, we're talking about typically units measure like mass, volume, and length. There are others in science, obviously, but the most common ones you'll come across in your most of your science courses are these three: mass, volume, and length. So dimensional analysis gives you a methodology to deal with different units of measure. If you think about mass, mass can be in grams, it can be in pounds, kilograms, like that, and volume has its own with liters or gallons and etc. So those are your different units for your different dimensions. And so what typically happens when you're working a problem is you're given information in the problem in a given unit, but your answer needs to be in a different unit. So your needed unit for your answer is going to be different. For example, maybe you start with kilograms. The problem gives you a quantity in kilograms, but they want their answer in milligrams. So at some point you're going to need to convert from kilograms over to milligrams, and dimensional analysis is the methodology you use to do that. So if we start, before we start, there are other videos you'll see in our lccc YouTube account. There are videos that go over the different units of measure for those dimensions of mass, length, and volume. So you can go look at those to get familiar with the different conversions within those dimensions. But if we look at a simple problem here of a need to do, say, one conversion factor. The problem very simple. We can do something like we start with liters and we want to go to milliliters. So here we can do this in one step. If you remember that there is in 1 liter there is 1,000 milliliters. So if you're given a problem, say you have 3 liters and you need to give your answers in milliliters, you would multiply by this conversion factor where 1 liter is 1,000 milliliters. And what power of dimensional analysis is you put the unit down here below for the one you want to cancel out from your given unit, and here's your needed unit in milliliters. In this case, your answer would be 3,000. So you start with a given unit, in this case 3 liters, and you're going to multiply by the factor where some conversion where the given unit, in this case liters, is on the bottom, and your needed unit is on the top. Therefore, the given units cancel out and your answer is in your needed unit. Just to do sort of the opposite to see how, almost the same problem, but let's do it a little differently. Instead of starting with liters and going to milliliters, let's start with 3,000 milliliters, and we want to go to liters. So again, our given unit, it's going to be our term, it's 3,000 milliliters. And now we want to use that same conversion factor of 1,000 milliliters and 1 liter. Only this time the milliliters are going to be on the bottom in 1 liter, so that the given unit here, milliliter, will cancel out, and our needed unit here, liters, is on the top, and so our answer here would be 3 liters. So this factor, this conversion factor of 1 liter equals 1,000 milliliters, can be flipped upside down depending on how you need to work your problem. So you can flip it over up or down depending on your given unit over here and what you'd want to get as your needed unit at the end. And another thing to remember, and we go over this somewhat in our other video, is that this conversion factor here is essentially, it's equal to 1. 1 liter is 1,000 milliliters. So what you're doing, even though you're converting from milliliters over to liters, you're just taking the number you have here, and you're just multiplying it by some factor that's really a 1. And therefore your answer, though it ends up in liters, you really have, it's an equivalence. Some of your textbooks will call this factor here of 1 liter is 1,000 milliliter. They'll call that an equivalence. It's essentially they're equal. It's really just a multiplication by 1, which doesn't really change your final quantity. You're just changing the units. Okay, now if we erase this and now move to 2 conversion factors. So if we change this 1 to a 2 conversion factors. In this case, let's say we want to go from liters as a given unit, and we want to go to microliters as our final answer. Now, you can do this in one factor if you know how many the conversion, say, from liters to microliters, or because microliters is smaller, how many microliters are there in a liter. But you may not, you're not going to have the entire number of possible combinations and conversion factors memorized in your head. You're going to have some key ones or some key factors in your head. And so what you'll see sometimes is you may have to go through a second level of factors. It's typical that most people know how to go from liters to milliliters, and then they may know the factor to go from milliliters to microliters. So instead of doing this in one step, in order to go from here to here, you would do it in 2 steps. A way to think about this is taking an airplane trip. Sometimes if you got a plane here and you're trying to go from let's say California and you're trying to go to New York, there may not be a flight all the way direct from California to New York at the time you want to go, but you might be able to go from California to Chicago and then take a flight from Chicago over to New York. So you make a stopover, you go and you have a step in the middle here in order to get to the end. And that's basically what you're doing, because you may not remember all the possible combinations of conversion factors. So in this case, in this problem, if we had, say, 3 liters, we can, maybe we know in our head like before, well, we know there's 1,000 milliliters in 1 liter. And that gets our given unit of liter up to milliliters. But our needed unit is microliters. So we have to just do one more step where you put your microliters below so it cancels. And so I say microliters, milliliters below. So you cancel your milliliters out. And 1 milliliter has 1,000 microliters. And now we have our needed units of microliters. And if you do your multiplication, you'll end up with 3 million or 3 times 10 to the 6 microliters. So occasionally you'll have to do 2 steps here, 1 and 2. And as your problems get more and more complex, maybe you need 3, 4, however you need in order to get from your given unit to your final unit. So they can just tag along and you just continue to do it until you get to where you need to be. So now let's look at, we've been talking so far, staying within the same dimension. We're going from liters, say a volume, we're going from one volume to another volume, or going from one mass to another mass. Well, there are also dimensional analysis can be used to change your dimension. In a very typical way that this, we'll use an example of, you start out with a volume, or you're given a volume, and you're asked to find an equivalent mass. And so now we're going to be switching units, but also your dimensions from a volume over to a mass. And we'll do an example to do this. Let's start with, say we're given here that we have 3.5 liters of some fluid, and we want to get to a needed unit, or what we want to get to is a milligrams, a mass. Okay, this is mass. So we're going from volume and we're going to mass. Now, because we're changing dimensions, we're going to need a conversion here from volume to mass, mass to volume. We're going to need a conversion. Very typically, a lot you'll see, you'll learn and use density, because density is a mass per unit volume. So that's a common way to switch those dimensions, is by using a density of a fluid. And so in this problem, you would either have to know a density of the fluid you're on, or that it would be provided by the teacher or in the problem. They'll be provided, and let's say in this case that this particular fluid, there's 0.48 grams per milliliters. So now you have a setup. Let me move this. Let me put your density over here so we have room. Density is 0.48 grams per milliliter. So one way to start with a problem like this, because it gets a little bit more confusing, is to think about, well, how am I going to, what's my path going to be to go from liters, is what I'm starting with, and I'm trying to get to, in this case, milligrams. So somehow I'm going to go from liters and I got to get to milligrams. And I know I'm provided with a density here, so I know at some point I'm going to use this grams per milliliter factor. And it'll be grams over milliliter, because I'm trying to get to mass. So my mass is going to be on top. I'm trying to eliminate the liters, so the milliliters is going to be in the bottom on this conversion factor here. But I have liters, and I just can't go right to milliliters. I'm going to need to put in a factor here. I'm going to have to eliminate my liters and convert that to milliliters, so that once I use this factor, my liters will cancel out. I'll have milliliters, and now my milliliters will work with the density very well and get me to grams. But I'm also not done, because I'm trying to get to milligrams. So I'm going to have to use another factor. I'm going to have to put the grams on the bottom so that I cancel out my grams, and up here go to milligrams. So I need a gram per milligram factor to get me there. So I essentially need three factors. I need a milliliters to liter factor. I need a grams per milliliter, which was provided in the problem. And I need a milligram to gram conversion to do this problem. So a way to look at this path when you're done here is you're going to go to liter. You're going to convert that liter to milliliters. Then you're going to convert the milliliters using the density to grams, and then from the grams you're going to go to milligrams. So your overall path will be through this method or this direction. So if we now do the problem, we're going to start with 3.5 liters. Now we have to change that liters to milliliters. We know in 1 liter there is 1,000 milliliters, which you should have memorized. Then we apply our density. There's 0.48 grams in 1 milliliter for this fluid. And then to get to milligrams, we know that in 1 gram there is 1,000 milligrams. And so our liters cancel here, our milliliters cancel, and our grams cancel. Our answer will be in milligrams. And if you do the math here, you'll end up with 1,680,000. And to throw in one other step here, and I have a video on significant figures. When you do this problem, the significant figures here, you have 2 significant figures in your given. These are exact numbers here, so they do not get involved in significant figures. So your answer needs to be in 2 significant figures. And so the correct answer here would be 1,700,000 milligrams, or if you wanted to use scientific notation, 1.7 times 10 to the 6 milligrams. So hopefully that gives you a nice review on dimensional analysis, and you realize how powerful it'll be when you're working with problems in science. Thank you.